Good morning, students. In the previous video, we discussed about equation of the tangent and normal at x1, y1 to the parabola y squared equal to 4ax. Instead of x1, y1, they may be give any point, or another one formation is instead of x1, y1, parametric equation is also given. That means for the parameter t equal to some numbers, t equal to 5. Then we have to convert x equal to 80 squared, y equal to 280. With the help of the parametric, we worked out. Again, one more type of tangent we already worked out. For example, y equal to mx plus a by m. In terms of slope, we are already worked out in terms of slope. That may be, question may be asked like this. The tangent is parallel to the given line, or the tangent is perpendicular to the given line. So we are able to find out the slope from the given line, and if parallel means we are able to select the same slope. Then if the perpendicular means, then m1 into m2 equal to -1. After that we are able to get the required slope. Then we are able to use the formula y equal to mx plus a by u. These three types of tangents we already worked out in the previous video. And one more question we already discussed. Find the point of intersection of the tangents at t1 and t2 to the parabola y squared equal to 4ax. That means two tangents can be drawn at t1 and t2 to the parabola. Then the two tangents intersecting at one point. Therefore, we are able to solve the two equations. Then we are getting the point of intersection. Today also, we are going to work out the same type of one more question. See the concept here. If the normal at t1 again meets the parabola y squared equal to 4ax at t2. Listen to the question. If the normal at t1 again meets the parabola y squared equal to 4ax at t2, then prove that t2 equal to minus of t1 plus 2 by t1. So we are going to prove this one. So normal, we need the normal at t1 again meets the parabola. This is only one normal. Meets the parabola y equal to 4x, that's standard equation, at the point t2. So we are going to prove this concept t2 equal to minus of t1 plus 2 by t1. Listen carefully, very simple concept only. So we are able to work out with the help of the diagrammatic explanation. See the question now. We need the parabola y squared equal to 4ax. We need the parabola y squared equal to 4ax. So this is the equation of the parabola type number 1. So now, first I am drawing a tangent. So this is to be tangent. Then this is the parabola y squared equal to 4ax. Now we are going to draw a normal. Listen carefully. This is the normal. So already well known definition. It is a perpendicular line to the tangent at the point of contact. Now we are selecting the point of contact as t1. So this is to be normal. This normal at t1 again meets the parabola at t2. So this is the given statement. So normal at t1 again meets the parabola at t2. Then we are going to prove that given condition. Now listen, what is the meaning of t1? A t1 squared comma 2a t1. This is nothing but parametric. Here a t2 squared comma 2a t2. So this is the diagrammatic explanation of the given question. So what is the meaning of t1 and t2? It is nothing but the parametric equation. In general, what is the meaning of t? T refers as the point at squared comma 2at. It is a parametric representation. So t refers the point at squared comma 2at. Here t1 means at1 squared comma 2at1. Just add the letter t1 t1. Again t2 means at2 squared comma 2at2. That's all. So now we are going to proceed the concept. Then we are able to apply the proof. T2 equal to minus of T1 plus 2 divided by T1. So just listen the diagram, understand the question, then we are able to prove the given one. So normal at T1 required. Now write the explanation with the help of this diagram only. Then what is the standard equation? So select the equation of the parabola. So you make the sentence very simple. What is the equation of the parabola we are selecting? Y squared equal to 4ax. So write down y squared equal to 4ax. Just one line we are able to produce. Then what is the meaning of T1 and T2? Let T1 a T1 squared comma 2a T1 and T2 a T2 squared comma 2a T2 be any 2 points. Be any 2 points. Any 2 points on the parabola. On the parabola. So we are able to write the sentence with the help of the diagram. No need to memory anything. So what is the type of the parabola? Y squared equal to 4x. Write one sentence. Equation of the parabola y squared equal to 4x. What are the points we are selecting? T1 and T2. It is nothing but the parametric. What is the parametric? at squared comma 2at. Instead of t, one time use the t1, second time use the t2. That is the second sentence. Let t1 at1 squared comma 2at1 and t2 at2 squared comma 2at2 be any 2 points on the parabola. Now we required equation of the normal. Equation of the normal at t1. Already we are having the general equation. See, equation of the normal at t. This is the general information we already worked. xt plus y equal to at cube plus 2at. This is the formula we already derived in your derivation part. Equation of the normal at t. xt plus y equal to at cube plus 2at. This is the normal at t. But we need normal at t1. Therefore, write a sentence here. Equation of the normal at t1. See here, instead of the general formula, we are using t1. Then what is the procedure? xt1 plus y equal to at1 cube plus 2at1. See, instead of t, use t1. That's all information. So xt1 plus y equal to at1 cube 2at1. No need to memory this line. Always keep this concept. xt plus y equal to at cube plus 2at. This is also derived from the standard equation. Already we explained in your theoretical concept. So just recall the things. Instead of instead of t, use t1. See here, this normal, again see, this normal passing through the point t2. Now we are going to make one more sentence. This normal, again passing through the point, see here, this normal, again passing through the point t2. So this normal again passes through, again passing through T2. So what is the procedure? If this equation again passing through the one more point, again we are going to substitute here. So now listen, instead of x comma y, I want to replace this at2 squared comma 2at2. Now listen this one. So this equation becomes, instead of x, I am going to replace at2 squared. Already you are having one more t1. Then plus, instead of y, 2at2. equal to, in your RHS side, a T1 cube plus 2a T1. Listen this once again. This is the equation of the normal. So we need the equation of the normal. This is the equation of the normal at T1. Again, this passing through the point T2, that is a T2 squared comma 2a T2. So this equation again passing through the point T2. That means substitute instead of this x, substitute the point. So we are getting a T2 squared T1. Again 2a T2. In your RHS side, a T1 cube 2a T1. Now listen this equation. In all the content, all the equation having the letter a here, all the terms having the letter a. Therefore, I am able to divide the given equation by a. So I am able to divide this equation by a. So if you are dividing, we can get T2 squared T1. A will be removed, T2 squared T1 plus again 2T2 equal to, in your RHS side, A will be removed, we can get T1 cube. Again A will be removed, we can get 2T1. Now listen this equation. Here T2 squared T1, therefore it must be a cubic. Here also we are getting one more cubic. Convert the cubic function in the same family. The remaining 2T2 here, 2T1 convert into the other side. So I am converting T2 squared, again T1, convert this one, minus T1 cube. So again already in your RHS side you are having 2T1, convert this 2T2 into the other side. So now we are able to take out from this T1 as common. Then T1, if you are taking T1 as common, what is the remaining? T2 squared minus T1 squared. In your RHS side, we are able to take out 2 as common. The remaining is T1 minus T2. So now it is in the form of a squared minus b squared. It can be split like this. T2 minus T1. Again T2 plus T1. See in your RHS side 2 now. Listen. Here in your LHS side, T2 minus T1 we are getting the factors T2 minus T1. But in your RHS side you are having T1 minus T2. So I wish to interchange this one. Therefore if you are interchanging we can get the negative here. T2 minus T1. Listen this line carefully. This is the important place. See the difference. You are getting T1 minus T2. I am taking out negative from this. Therefore it will become T2 minus T1. What is the need? T2 minus T1. Here also we are getting the same factor T2 minus T1. It will be removed. Once again listen. Normal at T1 passing through this normal means normal at T1. Again passing through the point T2. What is the meaning of T2? A T2 squared 2A T2. Therefore x comma y should be replaced. This equation passing through means, this normal passing through means, in that normal replace x comma y. Then we are getting this result. This entire, all the terms having a, therefore divided by a. So then we are getting this one. See this one. T2 squared T1. It having the cubic. Here also cubic. Convert the cubic family one side, the remaining other side. From this we are able to take out T1. Then we are getting T2 squared minus T1 squared. Here we are able to take 2 T1 minus T2. Then it is in the form of a squared minus b squared. It can be factorized T2 minus T1. Again T2 plus T1. But in your RHS side, you are having the factor T1 minus T2. Therefore, interchange, take out the negative. That means interchanging means take out the negative. So if you are taking the negative here, minus 2, T2 minus T1. Now the common factor must be removed. Now what is the remaining? T1. In your LHS, T1. The remaining factor is T1 plus T2 equal to, in your RHS side, you are getting minus 2. So after removing the common factor, you are getting T1 of T2 plus T1. So T2 plus T1, RHS side minus 2. Now it can be simplified. See here. So T1, I am keeping this factor T1 plus T2 here. Then it can be written as minus 2 by T1. That means this multiplication T1. So we are getting the division here. T1 plus T2. So it will be divided by minus 2 divided by T1. So we need the proof T2. So convert to the other side. It will become minus T1. Then minus 2 by T1. Take out negative common. So T2 equal to minus of T1 plus 2 divided by T1. This is the required proof. T2 equal to minus of T1 plus 2 by T1. So dear students, first read the question, then draw the diagram, then what is the concept given? Tangent at T1, tangent at T2. That is the previous question we already discussed in the previous video. So tangent at T1, tangent at T2 means, read the word correctly. T1, T2, we are drawing two tangents. That is the previous question. But in this question, normal at T1 again meets the parabola at T2. That means we are having only one normal. This normal again passing through the point. That is the concept different from the previous. So you have to understand. Then recall the concept. What is the meaning of T? Generally T refers the parametric. So we need T1 and T2 means just input T1, T1, T2, T2. Then take the standard formula. What is the formula of the normal at T? xt plus y equal to at cube plus 2at. In that T replace T1. Then that normal passing through this point. If a equation passing through a particular point, replace x comma y instead of this. Substitute this value. Then after that you have to analyze. See the question. It all the terms having a. So divided by a. After that, how we are able to simplify it is the logic. See the cubic, convert the cubic one side, the remaining other side. Then after that we are able to take one common letter T1. Then the remaining in the form of a squared minus b squared. It can be splitted. This is the most important place. Many students are directly cancel this one. This is the important. T2 minus T1. Here having T1 minus T2. So you are straight away not able to remove. Therefore interchange. This is the concept you have to understand. Thus take out the negative. After that remove the common factor. Then you are able to simplify. This is the one of the concept you have to learn. What is the difference from the previous? There we needed two tangents at T1 and T2. Here one normal at T1. That is the different. Try yourself and follow this one. Then the second question, the remaining one. The same, you are also going to discuss about equations of the tangent and normal. That is the concept we are going to discuss. Now listen. Already in your theoretical concept, we worked out two tangents can be drawn from any point outside to the parabola. We already worked out in the same logic for ellipse and also for hyperbola. So we are able to draw two tangents from any point outside the parabola, any point outside the ellipse, any point outside the hyperbola. In this concept, we are going to work out one problem. Listen, find the equations of two tangents. Find the equations of two tangents that can be drawn from the point, point 5 comma 2, that can be drawn from the point 5 comma 2 to the ellipse 2x squared plus 7y squared equal to 14. 2x squared plus 7y squared equal to 14. Read the question, understand what we are going to discuss. Find the equations of two tangents. This is an important word, two tangents. That can be drawn from. What is the meaning of from? That point should be outside. Therefore, from the point 5 comma 2 to the ellipse 2x squared plus 7y squared equal to 14. So, simply we can understand. See, this is the standard type number 1 ellipse. Just draw a simple diagram, then you can understand very easily. So 5 comma 2, take 5 units and 2 units here. I am taking a point 5 comma 2 outside the ellipse. Now see, from this point we are able to draw 2 tangents. So see this one. So from this point outside the ellipse we are able to draw 2 tangents to the ellipse. So this is the logic given in your question. So dear students, first read the question, understand what we are going to work out. So here the standard equation of the ellipse is given, 2x squared plus 7y squared equal to 14. So convert in the standard form and find out the values of a squared, b squared. That means I want to divide the given equation by 14. Then it will become 2x squared by 14 plus 7y squared by 14 equal to 14 divided by 14 1. 2 and 17, sorry, 14 will be simplified. Therefore, we can get x squared by 7 plus y squared by 7 and 14 will be simplified. We can get 2 equal to 1. From this, we are able to get a squared equal to 7, b squared equal to 2. So this is the first required condition. First required condition, we are able to work out a squared, b squared. Now, we are going to work out 2 tangents. At the point is not given. So at means either x1 comma y1 or at parametric. Parametric means for an ellipse theta must be given. So here no the point, that means not given at x1 comma y1 and also not given at theta. So we are able to work out in terms of slope. That is the logic. Recall the concept. Equation of the tangent to the parabola, to the ellipse, to the hyperbola. We already worked out the conditions. Y equal to mx plus c. Recall that condition. Condition for the line y equal to mx plus c to be a tangent to the parabola, to be a tangent to the ellipse, to be a tangent to the hyperbola. Refer the theoretical concept already we discussed. Now equation of the tangent. Equation of the tangent. Y equal to mx plus c. Instead of that c, we already derived the condition square root of a squared m squared plus b squared. Recall your basic conditions. Equation of the tangent. That means we already worked out the condition. Condition for the line y equal to mx plus c to be a tangent to the ellipse is c squared equal to a squared m squared plus b squared. We want c. That means plus or minus square root of a squared m squared plus b squared. This is also said to be a tangent in terms of slope, where m is called slope. Now this is the concept. Now just now we worked out the values of a squared. Now a squared equal to 7, b squared equal to 2. From the ellipse just now we worked out. Therefore this equation may be modified like this. Y equal to mx plus or minus, instead of a squared I am using 7m squared. Instead of b squared I am using 2. Now this equation passing through the point, this equation passing through, just refer this diagram. From 5 comma 2 we are drawing 2 tangent. That means both the tangent passing through the point 5 comma 2. Therefore this equation passing through the point 5 comma 2. A particular equation passing through a point, we are able to replace x comma y. Therefore I am replacing this y. Y is here 2. So that means 2 equal to mx. That means x value is 5m. Then plus or minus. That means x is replaced by 5. Carefully listen. X is replaced by 5, then 5m. Plus or minus, we are having square root of 7m squared plus 2. In the theoretical concept itself, I already explained. If you are getting a root family, keep that root family one side, convert the remaining in the other side. We already discussed the same concept. Where we are discussed, recall the concept. The locus of point of intersection of the perpendicular tangents. We already discussed this concept. You can refer that one. The locus of point of intersection of the perpendicular tangents to the ellipse. That is called a director circle. We already derived. Refer that to theoretical. So that I am discussing all the theoretical concept. All these theoretical concept you need. So that recall that one. 2 equal to 5m plus or minus square root of 7m squared plus 2. So I am keeping this root family one side. The remaining is 2 minus 5m is equal to plus or minus square root of 7m squared plus 2. So if I want to remove the root, then squaring both sides. After that we are getting LHS side a minus b the whole square formula. We are able to simplify, then we are able to get two values of m. Refer that theory. In that theory already discussed. Solving this equation we can get two values of m, say m1 m2. Now we are able to see that logic here. Once again listen students. Equation of the tangent y equal to mx plus or minus square root of a squared m squared plus b squared. Why we are selecting this particular equation? That is the logic behind this. Why we are selecting at x1 comma y1. At x1 comma y1 is not given. At the parametric theta is also not given. Therefore the remaining one equation is y equal to mx plus or minus square root of a squared plus m squared plus b squared is also the equation of the tangent where m is said to be the slope. So we are taking this one. Now listen. So we are getting 2 minus 5m plus equal to plus or minus square root of 7m squared plus 2. Now I want to remove the root family. Now listen, squaring both sides. Squaring both sides. That means if you are squaring both sides means 2 minus 5m whole square we are getting. In your RHS side plus or minus will be removed, root will be removed. Therefore we can get 7m squared plus 2. 7m squared plus 2. Now listen, it is in the form of a minus b the whole square. Expand this one. 4 minus 2 2s are 4, 4 into 5, that means 20m plus here 5m squared, that means 5m the whole square means 25m squared. Then convert the same side, we can get minus 7m squared minus 2 equal to 0. Listen once again, it is in the form of a minus b the whole square. You expand this, 2 squared becomes 4, then minus 2ab, 2 into 2, 4, 4 into 5, minus 20m, 5m the whole square is 25m squared. Convert in the same side, we can get minus 7m squared minus 2 equal to 0. Now, 25m squared, 7m squared, it will be simplified. We can get 18m squared minus 20m. Then 4 and minus 2 will be simplified. We can get plus 2. This equation can be divided by 2. Therefore, we can get 9m squared minus 10m plus 1 equal to 0. So 9m squared minus 10m plus 1 equal to 0. Listen once again students. So no need to memory. Just apply the what we are discussed in your theoretical part. So listen the theoretical part first. Then you are able to work out the same concept. Apply the same concept. Already we discussed in this. It will be produced two values of m. So see here 9m squared minus 10m plus 1 equal to 0. It is a quadratic equation. If we are solving this equation, we can get two values of m. With the help of two values of m, we are able to draw two tangents. Now listen. After expanding this, a minus b the whole square, convert the same side, then we are getting 18m squared minus 20m plus 2 equal to 0. 9m squared minus 10m plus 1 equal to 0. Now we have to factorize this one. If you are multiplying 1 into 9, we can get. So split this one. We need minus 10. So minus 1 minus 9 will produce positive. When we are simplifying this one, we can get minus 10. So the starting equation with 9. So first I write in the normal method 9m squared minus 9m minus 1m plus 1 equal to 0. So we are able to take 9m as common. The remaining is m minus 1. Here I am able to take minus 1. The remaining is m minus 1 equal to 0. Here m minus 1 is the common factor. Take one common factor. The remaining is 9m minus 1 equal to 0. From this I can write m minus 1 equal to 0. One value of m equal to 1. M minus 1 equal to 0. I can get one value of m. Again 9m minus 1 equal to 0. The remaining value is 9m equal to 1. So m equal to 1 by 9. So these are the two values of m. Now recall your theory. It is a quadratic equation in m. By solving this equation, we can get two values of m. Say m1 and m2. With the help of two values of m, we are able to draw two tangents. That is the logic. See this quadratic equation. In this quadratic equation, we are able to factorize. We are able to get m equal to 1, m equal to 1 by 9. So with the help of this, so we have already quadratic equation solved in your 10th standard. You already discussed the same concept. Without using this method, directly we are able to produce. What is the procedure? Just we need 9, minus 1, minus 9, minus 10. So starting with this equation, coefficient of m squared is iron. So if I am dividing by 9 here, so now minus 1 by 9, it will be simplified minus 1. Therefore, from this, the value of m equal to positive value. Here negative means positive. Here m equal to 1. So same logic only, we are able to get m equal to 1, m equal to 1 by 9. Here also we are able to get. So whatever method you can use, but we need two values of m. That is the logic. From these two values of m, we need equations of two tangents. Just now, I draw a diagram. Just to recall that already we discussed, this is the first standard type of ellipse, type number 1. We need equation of the two tangents. We need the equations of the two tangents. Just I draw a diagram before. This is the point 5, 2. So now, this is tangent number 1. This is tangent number 2. We need equations of these two tangents. Just to recall, point is given 5, 2. We are having two slopes. Then from your lower classes, point and slopes are given. That means m is given. So what is the procedure we are able to work out from your lower classes? We are able to work out equation of the tangent. From your 10th standard or 11th standard already used. Equation of the tangent. Equation of the tangent. From your 10th standard used. Y minus y1 equal to m of x minus x1, where m is the slope. x1 comma y1 is the given point. Now, what are the values of m? m equal to 1. So I am using the first condition. If m equal to 1, point is same. If m equal to 1, point 5, 2. I am going to substitute here. See, y minus, what is the value of y1? 2 equal to, what is the value of m? 1. X minus, what is the value of x1? 5. So substitute the point x1 comma y1 here. So this means x1 5, y1 2. Simplify this one. Y minus 2 equal to x minus 5. Convert this equation the same side. So x minus 5, then minus y plus 2 equal to 0. So x minus 5 already convert into the other side, minus y plus 2. Therefore this equation can be written in the form of x minus y. 5 and 2 will be simplified. We can get minus 3 equal to 0. This is the equation of one tangent. If m equal to 1, then point is already given 5, 2. Then substitute in this equation. So we already having this formula y minus y1 equal to m of x minus x1 is the equation of the tangent or equation of the straight line. You already used the equation of the straight line in your lower classes. But the straight line is nothing but a tangent. So we are using y minus y1 equal to m of x minus x1. In the same way, see now, this is the first condition. If m equal to 1, point is 5, 2, substitute and simplify. This is tangent number 1. We are able to get T1. Say tangent number 1. Just I am giving. So the same condition, same formula we are going to use. What is the slope of the second? The second point is if m equal to 1 by 9 and the point is same only. So here see the point. Both the tangent passing through the same point. Therefore point is common. Slopes only different. Therefore point if m equal to 1 by 9, point 5, 2. Once again I want to substitute here. y minus, what is the value of y1 here? See x1 comma y1, 2. Now what is the value of m? 1 by 9 x minus, you see x1 is here, x1 comma y1, 5. So now 9 will be cross multiplied. 9 is multiplication with y, we can get 9y. 9 is multiplication with 2, 9 2s are 18 is equal to 1 here, x minus 5. Again converting the same side, x minus 5, then minus 9y, minus of minus, plus 18 equal to 0. Now x minus 9y, 5 and 18 will be simplified, we can get 13 equal to 0. So this is the equation of the second tangent. With the help of the slope, already recall the theory. You are getting two values of m, say m1 and m2. With the help of two slopes, two tangents can be drawn. Already discussed in your theoretical concept. Now you are able to see that concept. You are able to work out the concept. Two values of m equal to 1, m equal to 1 by 9. With the help of m equal to 1 and m equal to 1 by 9, we are able to work out two tangents. Just keep this formula. Equation of the tangent. Equation of the tangent, y minus y1 equal to m of x minus x1. Instead of m, we are using the slope number 1. M equal to 1, point is C. Then m equal to 1 by 9, that is the second slope. Point is 5 comma 2. Substitute here, simplify. Then cross multiply this 9. 9y minus 18 equal to x minus 5. Convert into the same side, x minus 5 minus 9y plus 18. This must be simplified, x minus 9y. 18 and 5 simplified, we can get 13. This is also the equation of the tangent. So dear students, just work out all the theoretical concept. If you are well versed in your theoretical concept, then you are able to work out any type of problems then given in your book. Just to recall, what is the given concept? If the point x1 comma y1 is given, just to recall, what is the formula to find the equation of the tangent at x1 comma y1, and what is the formula to find the equation of the normal at x1 comma y1? Just to recall and substitute at x1 comma y1. Instead of at x1 comma y1, parametric is also given. What is the parametric for parabola? X equal to 80 squared, y equal to 280. T must be given in your question. That is for parabola. Then for an ellipse, already we discussed this type of questions. If theta is given, then we need the parametric. What is the parametric for an ellipse? X equal to a cos theta, y equal to b sin theta. Instead of theta, they may be given any angle. Then a comma b, you can get from the equation of the standard equation from the ellipse. You are able to derive a comma b. Then substitute, you are able to get the point x1 comma y1. After that, the same process. Equation of the tangent at x1 comma y1. In the same model, if theta is given for a hyperbola, that is also the parametric equation. For a hyperbola, what is the parametric equation? X equal to a secant theta, y equal to b tan theta. We need theta, so that theta is called the parameter. Theta must be given in your question. Then a comma b, we are able to take from the standard equation of the hyperbola. Then substitute, we are able to get x1 comma y1. This is the concept first. We are already worked out these type of questions. Suppose parametric equation not given, and also x1 comma y1 is not given, then we need the equation of the tangent. That concept also discussed in your theoretical concept. What is the formula? Y equal to mx plus c. Instead of c, for a parabola a by m, instead of c, we are already worked out the condition c equal to plus or minus square root of a squared m squared plus b squared for an ellipse. That concept we are used for this question. Therefore, dear students, just recall the concept, try yourself, apply, we are able to get any type of questions, use your concept. Thank you.